Okay, fantastic. So let's review some chemistry. So uh, carbohydrates contain carbon, hydrogen, and oxygen. The hydrocarbon chain, which is hydrophobic, contains carbon and hydrogen. Proteins uh, containing carbon, hydrogen, oxygen, nitrogen, and possibly sulfur. Uh, Ammonia is NH3, nitrate is NO3 minus 1. The carboxyl group, this will definitely be a question. So it contains the carbonyl group and the hydroxyl group. So C double bond O is the carbonyl and hydroxyl is OH. Hydroxyl group is released by bases. The hydrogen is called the hydrogen ion or proton and is released by acids. The amino group is NH2 or NH3 plus. The OH bond is electronegative because oxygen attracts electrons and tends to uh, create a situation where the electrons are shared unequally and the electrons spend most of their time around oxygen. Okay, this is what I just said. In an OH bond, electrons are clustered around oxygen. Oxygen is slightly negative and hydrogen has a slight positive charge. Hydrophobic means water fearing. Hydrophilic means water loving. Okay, so let's look at the amino acid structure. So this is the nitrogen of the hydrophilic nitrogen group. Nitrogen is also electronegative. This is the carboxyl group with C double bond and O, and this is another oxygen. The grays are carbon. This is the central atom. Remember, this is oxygen. I'm sorry, carbon. Carbon, and these are the hydrogens of the hydrocarbon chain. So this particular amino acid has, of course, the carbonyl group, the amine group, and a hydrocarbon chain, and it is uh, leucine. So you can take a look down here. Uh, so this part of the molecule will be hydrophobic because it's all carbon and hydrogen. This part will be an electronegative oxygen here, these electronegative oxygens, and the electronegative nitrogen. So this makes this the polar part of the group. So it's very important that molecules have three-dimensional shapes and hydrophilic regions and hydrophobic because that allows proteins to be put together using amino acids and allows proteins to have thousands and thousands of combinations of amino acids and have properties based upon which amino acids are used to make a protein, because the position of the amino acid in the protein chain determines the properties of the protein. So all the amino acids used to build a protein give the opportunity to create hydrophobic places and hydrophilic areas within a protein, and that can greatly influence the properties of proteins, which are enzymes. And enzymes are the large proteins that allow the activation energy of reactions to be lowered. So reactions that would not take place unless at a higher temperature, then we would have, I'll come back to that. Let me admit this person, okay? So we're back to right here. Okay, so proteins are polymers of amino acids. the placement of amino acids in the protein chain based upon genetic information in the nucleus, and that information is transcribed onto messenger RNA. Messenger RNA is sent out of the nucleus, processed, and using ribosomal RNA and transfer RNA, the proteins are built with a sequence of amino acids, primary structure. So how the amino acids are connected and which amino acids are used with their varying hydrophilic areas and hydrophobic, that determines the incredible variety of structural proteins and enzymes, which are an organic catalyst. A catalyst promotes reactions without being used up. So there's the amine group, the carboxyl group, the central carbon. This is hydrogen. This is carbon. This is the hydrophobic chain of this amino acid called leucine. Okay, so I hope that, well, the purpose is to review. So the test is posted. The test is due on October 17th at 11:45. So you have 2 days to take it, no timer. Okay, so let's get rid of this page here. Let's stop the recording.